In this video, we're going to cover organic chemistry nomenclature continued by looking at more functional groups, so ethers, esters, amines, and amides. I do find that these functional groups can get complicated, but I just want to show you the basics today so you have an idea of how to approach the nomenclature. So these structures that we're going to name together are relatively straightforward. If you do encounter more difficult ones and you want to, have a question about it, please put it in the comments and we can chat about that. So let's start with ethers. Now we can recognize ethers by this kind of generic structure, R, oxygen, R prime. So R stands for a carbon chain, so a parent carbon chain. R prime stands for a shorter carbon chain, and that is actually going to be our substituent group. So for example, if I look at my first structure here, let's call this example A. I've got two carbon chains basically between an oxygen atom, and I can see that my longer parent chain is the one towards the left. So we're going to go ahead and number off our carbons. This is a 1, 2, 3, 4. So I know my carbon parent chain, it's a butane. It's a 4-carbon parent chain that is all singly bonded. So butane will be the suffix of the nomenclature, the ending. Well, what about the prefix? So remember that we always put substituent groups as the prefix. So here's my substituent group. It's a 2-carbon component hanging off of the oxygen. Now, because it's hanging off of the oxygen and this is an ether, we use the prefix oxy in front. So for example, this would usually be called ethyl, but now we're going to call this ethoxy. Okay, so this whole thing, if we put it together, it becomes ethoxybutane. Okay, so like I said, relatively simple one. And if we look at the second one for the ether, again, we just have to identify, we see the oxygen in the middle. So between two carbon chains, we have to figure out the parent chain and the substituent group. And my longer parent chain, in this case, it's a cyclical hydrocarbon. And if you recognize this structure, this is called benzene. Okay, so that's a very common structure we see in organic. That's my parent chain. This is going to be my substituent group, and it's a 1-carbon meth or methyl. But remember, because it's an ether, we're going to change it to methoxy. So if we put this together, this whole compound is called methoxybenzene. Okay, and again, those are some fairly simple examples of how we can tackle ethers. Let's go to the next one, which is esters. So esters are recognized by a specific functional group that looks like this. So it's C double bond O, single bond O. Now the C double bond O part, that's called carbonyl. And wherever we see a carbon chain connected to the carbonyl, that's this part, then this will become your parent chain. And then whatever you have connected to this single bonded oxygen, so whatever carbon chain you have there, this will become your substituent group. Okay, so this part is going to be your substituent group, the one that is hanging off the single bonded oxygen. And then the carbon chain, including this carbon that's connected to the carbonyl, this is going to be your parent chain. So that's important, again, just to recognize what you're looking for. And then again, for the nomenclature for esters, we do it very similar. Our parent chain ending, rather than having the ending in ane, the ending for esters will be O8. So esters will end with the suffix O8. So for example, pentane would become pentanoate, for example. Okay, so let's look at example A. We have a structure, we have our ester, and then we can notice that, I guess, around the ester, we have a substituent group. So that's this part that's hanging off the single bonded oxygen. And again, this is a 2-carbon compound, single bonded. So we're going to call this ethyl. And then my parent chain is going to be the one connected, remember, to the carbonyl. So the C double bond O. And we're going to number off our parent chain. So this is 1, 2, 3, 4. So there's 4 carbons in my parent chain. That's a butane, but remember, we're going to change the ending to O8, so butanoate. Now notice we have one more substituent group over here, right? We didn't identify that yet, that I circled. So there's also a methyl on carbon 3. Okay, so there's actually 2 substituents here, so we're going to put them in alphabetical order. My prefix will become ethyl -3 methyl. And then my parent chain, remember, is a 4-carbon. So ethyl -3 methyl butanoate. Okay, something else to notice is that carbon 1 is always going to occur where the carbonyl is. And same thing for the ether as well. So if you remember from previous functional groups, so for example, like carbon 1 will always be connected to that oxygen. Previous functional groups, carbon 1 may not always be connected there. So there are some functional groups where you have to identify on what carbon number does the functional group exist. But if it's always number 1, then the 1 is implied. So again, a lot of rules and it can get complicated. So try your best to practice and memorize these rules to the best of your ability. Okay, let's try another ether example here. This one's a little bit more straightforward. So again, identify your parent chain, identify your substituent group. The parent chain is going to be the one connected to the C double bond O. So here's my parent chain, 3 carbons, no substituent groups. Okay, so we only see bonds, again, single bonds. And then this will be your substituent group. So there's only one substituent here. This is a methyl. And then your parent chain is a 3 carbon, so that is a prop. But again, propane turns into propanoate. So we put all that together, this becomes methyl propanoate. Okay, so that's a relatively straightforward one, and that's how we tackle esters. So just try to remember, look for this kind of format that tells you what to look for, and it'll help you visualize these compounds. Okay, moving on to amines. So amines, they are going to have nitrogen bonded to 1 or 2 or 3 side groups. And the nomenclature is that we're going to change the ending from like ane, so like propane, we're going to change the ending to amine. So for example, propanamine. So amines end with amine. Okay, that's our nomenclature for the suffix. So if we look at an example, again, this is a straightforward one. I have my nitrogen and I have 2 substituents here. I've got a methyl, that's my 1 carbon. So this is a methyl, and I have an ethyl. And then I have a parent chain of carbons towards the left. And if we number these off, this is 1, 2, 3, 4, 5, 6. I've got a 6 carbon parent chain. And there are no other substituents on my parent chain. So my parent chain is a hexane. I'm going to actually do this one backwards. So my parent chain is a hexane, but we're going to change the ending to amine. So hexane 1 amine, I should say, because for amines, again, this is a kind of a distinction you'll have to study. The nitrogen is not always going to be on carbon 1, so I am going to indicate here this is a hexane 1 amine, and then my prefix is ethyl and methyl, and we're going to use the nomenclature N-ethyl, N-methyl, because these substituents are hanging off of a nitrogen, and we're going to put them in alphabetical order. So the entire name is going to be N-ethyl N-methyl hexane 1 amine. Okay, so complicated one, and again, I just chose one example for this one. Continue to research and practice for more additional examples and more complicated ones. But just remember that, again, the carbon 1 is not always going to be attached to the nitrogen. It could be attached to a different carbon number. Okay, let's do one more, amides. So amides you can recognize by the functional group C double bond O. So remember this carbonyl, and then nitrogen. And so again, I chose relatively simple examples. Let's look at the first one. I can see I've got a parent chain where my carbonyl is. So just like, remember, we did the example before. So if we go back, we did an example with esters. Remember how I said that esters, we're looking for the C double bond O, wherever that is, that's going to indicate your parent chain. So we see a very similar idea with amides. Okay, so that means C double bond O is here. So that means my parent chain, well, actually, and there is no other carbon chain on the other side. So my parent chain is 1, 2, 3, 4, 5. Okay, and amides, by the way, they end with amide. That's how we do the nomenclature. The suffix will be amide. So my 5 carbon is going to be pentane, will change into pentanamide. And there are no additional substituents here because in the nitrogen I just have hydrogens attached. So this structure here is called pentanamide. Okay, and then carbon 1 is just going to be where the double bonded oxygen is, so I don't have to put 1 in between. And then we're going to try one more. This one is slightly more complicated, but not that bad. So where the carbonyl is, this is carbon 1. My parent chain is like this, 1, 2, 3, 4. So automatically I know this is going to be a bute. Okay, 4 carbon bute. and butanamide and amide. Butanamide, and but there are substituents this time because we see that on the nitrogen we have these two methyls. So we're going to call this N dash meth. N comma N dimethyl, and this should all be one word. So N comma N dimethyl butanamide. That's how we name the structure. Okay, so complicated concept. If you have any questions, please put them in the comment section, and good luck studying organic chemistry, and hopefully this gives you a bit of a structure on how to start the concept. Good luck, and thanks for watching.